Chapter 5, section 4. What has chapter 5 been all about? Not elimination. Do what? Not linear equations. Nope. Nope. What has all of chapter 5 been about? No. Nope. What have we been solving?
Equations.
Nope. Nope.
Orders don't pop in the mind.
It's on the board.
Linear equations.
Not linear equations, but systems of linear equations. That's what chapter 5 has been all about, right? Systems of linear equations. A system is two or more equations that have the same variables, correct? So what are the three methods we've used to solve systems of equations? Yes? Substitution. What's another one? Yes? Elimination. And the last one, someone raise your hand for me. Substitution, elimination, and graphing. Very good. Today we're going to look at special solutions of our systems of equations. So let's get into it. A system of linear equations can have one solution, no solution, or infinitely many solutions. Those are our only three options. Okay? So we've already seen one solution a lot. If my graphs intersect at a point, that point is my solution, correct? Yes. Or if we've solved by substitution, we got our ordered pair using substitution, or we could get our ordered pair using elimination. Right? That was all one solution, just that one ordered pair. If my lines are parallel, are they ever going to intersect? So do they have a solution? No. So if our lines are parallel, we have no solution. They're never going to meet. We will look at substitution and elimination today with no solution. And then infinitely many solutions if my lines are the same line. They're on top of each other. They're intersecting at every point. Every single one of their points is touching, correct? Because it's the same line. That's infinitely many solutions because my lines go on forever and ever and ever and ever. Does that make sense? We good with all that? Okay, so I just got some examples for you. We're going to solve each example using graphing, substitution, and elimination to see what it looks like. Okay? So number 1. Solve the system of linear equations. Y equals 2x plus 1. Y equals 2x minus 5. Are these already in slope-intercept form?
Yes.
Yeah, so let's go ahead and solve by graphing first. Okay? So for the first equation, let's identify our slope and our y-intercept. Raise your hand if you can give me the slope. 2, very good. 2 or 2 over 1. Raise your hand if you can give me the y-intercept. There you go, 1. Questions about that? Are we all still okay graphing? What do I graph first? Y-intercept. So I put a point at 1 on my y-axis. And then I use my slope to get more points. Rise over run. Which two directions am I going and how many units? Up 2, right 1. It's positive 2. I'm going up 2. Over a positive 1, I go right 1. How many points do I want you to have? As many as you can fit on your graph. So I keep going up 2, right 1, so you can't get any more. So I've got all the ones to the right that I can get. Can I get any more to the left? Yeah, how do I do that? Yep, change the signs of my numerator and my denominator. So which two directions do I go now? Down 2, left 1. Once I get all the points I can get, connect my point to the line. Try to make your line straighter than mine. There's my graph of the first equation. Questions how I got that? Okay, second equation. Raise your hand if you can give me my slope. 2 over 1. Raise your hand if you give me my y-intercept. There you go, -5. Once again, graph your y-intercept first. Put a point at -5. And which two directions? For my slope. Up 2? Right 1, very good. Up 2, right 1. And same thing, down 2, left 1. Any questions how I graphed either of these lines? We're all good with graphing. Graph your y-intercept first. Use your slope to get more points. What do we notice about these two lines? They're parallel. I can tell from the graph. And what do I know about their slopes that make them parallel? They're the same slopes, right? So will these lines ever cross each other? Will they ever touch? No. So what's my answer here? No solution. So I can either write it out, no solution, or I can put my symbol for no solution, which is a circle with a slash through it. That's terrible. Hold on. Circle with a slash. You can use either one of those for no solution. Questions about it graphically? Can I erase and use substitution now to solve it? Okay, what do I need to happen in order for me to be able to use substitution? We don't remember. I need to solve one of my equations for, or one of my variables, right? Doesn't matter which variable. I need to solve one of them for a variable. Do I already have one solved for a variable? Yeah. Both of them have y by themselves, right? They're both solved for y. So I do have them, or one of them, solved for a variable, correct? So this top equation, what is it telling me y equals? 2x plus 1. So y and 2x plus 1 are interchangeable. They're the same. So with that being the case, what can I do with this y right here? Yeah, I can replace it with 2x plus 1, substitute it, because they're the same thing, right? Everyone kind of remember that from substitution. Now, I've got an equation with just one of my variables now. I just have x in it. So what do I do with this equation? Solve for x. Very good. So if I got the variable on two different sides of the equation, what do I need to do? Nope. Get my variables to the same side of the equation, right? So how would I bring one of my two x's to the other side? Subtract 2x. We've got to use our inverse operation still. What happens when I do that, though, when I subtract 2x from both sides? Cancels out all of my x's, right? Do I have any x's left? No. What's left on my left side of the equation? 1. What's left on my right side of the equation? -5. Is that a true or false statement? False. 1 does not equal -5, does it? So, when I'm using substitution, if I have variables cancel each other out like this, and I don't have any other variables, and I get a false statement, my answer is no solution. Does that make sense? If it tells me to check my solution if possible, am I able to check no solution? No, because I don't have any x or y values to plug in, do I? So that'd be the end of the problem right there. Okay? Does that make sense for substitution? If you substitute, that variable cancels completely out. You're left with a false statement, no solution. Can I erase and use elimination now? Sweet. Okay, elimination. This should be the freshest on our brains right now because we just did 3 days over it before today. What do I need in order? What do I need to happen in order to use elimination, to eliminate a variable? Same number, opposite sign in front of one of my variables, right? Do I have same number, opposite signs in front of one of my variables right off the bat? No. Do I have same number, same signs?
Yes.
Yeah, I do. So how do I change one of those signs on one of my variables? Yes?
Add the x.
Multiply by -1, so it'll just change the sign for me. Everyone remember that? Does it matter which equation I multiply by -1? No. So which one do you guys want to do, top or bottom? Top. Like I said, it doesn't matter. You can use either equation to multiply by -1. The whole equation gets multiplied by -1, right?
Yes.
So -2x times -1?
Positive 2x.
Positive 2x. -1 times y?
Negative 1y.
-1y or -y? -1 times 1? -1 times 1?
Or
-1. Questions how I got that? Now, do I have same number opposite signs in front of a variable?
Yeah.
Which one?
2 and 3.
Huh?
Probably 2 and 3. Or 2
No, which variable has the same number opposite signs in front of it?
X.
X? Are you sure?
Or y.
Huh? What? X and y, right? So let's see what happens when we add here. What happens to my x's? Huh? They're canceled out. They're eliminated. What happens to my y's? They're eliminated as well. So if everything's eliminated on the left-hand side of the equation, what am I left with?
6.
On the left-hand side?
Or no.
If everything's eliminated, what am I left with? Nothing. What number represents nothing? 0. Equals, what's -5 plus -1? -6. True or false statement?
False.
False. 0 does not equal -6. So what would my solution be?
No solution.
No solution. Does that make sense? Similar to substitution, if I'm using elimination and both of my variables get eliminated, and I'm left with a false statement, no solution. We good with that? Any questions on any of the methods I use to solve this system of equations? They're not touching. When you graph it, they're parallel, no solution. Substitute, variable cancels out, false statement, no solution. Elimination, both variables cancel out, false statement, no solution. Okay? Can I move on? Example 2. Solve the system of linear equations. -2x plus y equals 3. -4x plus 2y equals 6. Once again, we're going to use all three methods here to see what it looks like. Okay? Let's graph first. What form of the equation do I need in order to graph it? Bless you. Slope. Slope. Intercept form. So I got to get both equations solved for y. Right? So equation 1, the top equation, how do I get y by itself here? So add 2x, right? If I subtract -2, it's the same thing as adding it, right?
Yeah.
So add 2x to both sides. So I get y equals, can I combine 2x and 3?
No.
No, I have some people still trying to combine those. Are they like terms?
No.
No, so how would I write it?
3 plus 2x.
3 plus 2x or 2x plus 3. Questions how I got that? That one is now solved for y. It's in slope-intercept form. Equation 2. What would be my first step to get y by itself? Add
4x.
Add 4x to both sides. So I get 2y equals, can I combine 6 and 4x?
No.
No, so how do I write it?
Y equals
6 plus 4x, or 4x plus 6. Is y by itself yet?
Yes.
No, it's not. It's got the 2 with it. How do I get y by itself? Divide everything by 2. 6 divided by 2. 3. 4x divided by 2. 2x. What do I notice about these two equations? They're the exact same, right? So let's graph it real quick. What's my slope of these two equations?
2.
2 or 2 over 1. And what's my y-intercept? 3. Let's graph your y-intercept first. And go up 2, right 1. And down 2, left 1. Take your points. Oops. Put the arrows on your line. Now, that's my first equation graphed. If I were to graph my second equation, it would have all the same points, correct? So it'd be here, 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 here. All the same points. So that creates the same line. So if I get the same line, what's my answer? Where are these two lines intersecting each other? Yeah, they are. All the same points, right?
Yeah.
They're intersecting at every single point. Do these lines ever stop?
No.
No, so what's my answer? Infinitely
What's the sign for that? Like R?
many solutions. I want you to write out these 3 words.
Oh my.
Do not put IMS. Do not put the infinity symbol. Your answer is not infinity. Your answer is infinitely many solutions. Yes?
Can we put the infinity symbol many solutions?
No. It's not infinity many solutions. It's infinitely many solutions. Just write out these 3 words. It's not going to hurt you, I promise. You write more words than this in English class, you'll be okay.
I don't even be writing
We
it.
type it.
Okay, that's fine. You can write 3 words. It's not that hard. Infinitely many solutions. Do not put IMS. Do not put the infinity symbol. Do not put the infinity symbol many solutions. I want you to literally write out these 3 words. Everyone got me?
What if you spell infinity wrong?
Infinitely?
Yeah, infinity.
Don't. I got it up there for you. You know how to spell it now. Okay? Questions on graphing and getting infinitely many solutions. Same line, infinitely many solutions. Can I erase and solve by substitution now?
Yes.
Okay, substitution. What's my goal? What do I need to do in order to substitute? Solve one of the equations for a variable, right? I've already done that? Yeah. I solved the first one for y, right? By adding 2x to both sides. And I got y equals 3 plus 2x, right? Boom. Done. So what does y equal? 3 plus 2x. What does that mean I can do with this y in my second equation? Plug what in? 3 plus 2x. I can substitute 3 plus 2x for this y variable. Everyone okay with what I've done? Makes sense? Okay, now I've just got an equation with just x in it. What's my first step here trying to get x by itself? Distribute. Distribute this 2 through this set of parentheses. 2 times 3?
6.
6. 2 times 2x?
4x.
4x equals 6. after I distribute? What can I now do? What can I do now? Combine my like terms. What are my like terms? Negative 4x and? Nope. Negative 4x and?
Negative 4x.
Negative 4x and? What's the other thing with the x in it?
4x.
4x. Come on, guys. Come on, guys. You're worrying me here. What do I get when I combine those? What's negative 4x plus 4x?
Negative.
0x, right? They cancel out. What's left on that left-hand side? 6 equals, and I still have 6 on the right-hand side. Is that a true or false statement?
True.
True. So what do you think my answer is if the things cancel out and I'm left with a true statement? Nope. Infinitely many solutions. So if I substitute and those variables cancel each other out, I'm left with a true statement, infinitely many solutions. It's not just one solution, because did I get x or y by itself? Or did I solve for x or y? No. It canceled out, so I'm just left with a true statement, infinitely many solutions. Does that make sense for substitution and infinitely many solutions? Okay, last one. Can I erase and solve by elimination now? Good, because I'm already erasing. Okay, what's my goal when I'm wanting to solve by elimination? What do I need to happen? Same number, opposite signs, right? Do I have that right off the bat in front of either of my variables? No. Do I have same number, same signs? No, I don't. So let's look at our x values. Negative 2 and negative 4. Can I multiply negative 2 by anything to get to 4? 2, right? Let's see if a y value will be smaller than that. Can I multiply 1 by anything to get to 2? 1 times what gives me 2? 2. Right? So it looks like I'm multiplying that top equation by 2. But not just 2. I need opposite signs as well. So negative 2. Does everyone see that? Multiplying the top equation by negative 2. The whole equation gets multiplied by it. So what's negative 2 times negative 2x? What? Positive 4x. Golly. What are y'all doing today? Negative 2 times y. Negative 2y. Negative 2 times 3. Negative 6. Do I now have same number opposite signs?
Yes.
Yes, let's add them. What happens to my x values? Eliminated. What happens to my y values? Eliminated. Oh no, my variable's all eliminated again. What's left on the left-hand side? 0. What's 6 plus negative 6? 0. True or false statement?
True.
True. So what do you think my answer is?
Infinitely many
Infinitely
solutions.
many solutions. Does that make sense? That's my last example. So quick recap. If I'm solving by graphing, my lines intersect in one point, how many solutions do I have? 1. The point where they intersect, right? If I'm graphing, my lines don't intersect at all. They're parallel lines. What's my answer?
No.
Huh?
No solution.
No solution. And if I graph my lines and they're the same line, what's my answer? Infinitely many solutions. Does that make sense for graphing? Okay, if I'm solving by substitution, and I am able to get an x value, and I am able to get a y value, how many solutions do I have? 1. Whatever that ordered pair is that I get, right? If I'm solving by substitution, my variables cancel out after I substitute. I'm left with a false statement. What's my answer? No solution. If I substitute, my variables cancel out. I'm left with a true statement. What's my answer? Infinitely many solutions. Any questions on substitution? Elimination. If I get same number opposite signs and then both my variables cancel out and I'm left with a false statement, what's my answer? If I'm left with a false statement, no solution. Both my variables cancel each other out. I'm left with a true statement, infinitely many solutions. If I'm able to eliminate one variable, solve for a variable, plug back in and get my other variable, how many solutions do I have? One. Okay? Are there any questions, comments, concerns about any of our types of solutions or how we get them? Yeah?
Is it possible to get two?
No. Not with linear equations, at least. Now, in the future, you may graph what we call a parabola and a line. Then there would be two solutions there. But algebra 1, we're just dealing with linear equations. So you'll just get one, no, or infinitely many. Okay? Questions on our notes for today? Good? Here we go. Pages 249 through 250. Numbers 2 through 26 evens. Get this written down so I can turn the projector off. Do we have any questions about the notes that would pertain to the recording before I end the recording? Okay.